Earth feels solid, reliable, stable. We wake up every day assuming the planet beneath us will behave exactly as it did yesterday. But that stability is not guaranteed. It is maintained by a set of invisible systems, so precise, so delicate, that if even one of them fail, everything we know begins to unravel. This is not speculation. It has happened before, and the evidence is written into ice, rock, oceans, and extinction layers. This is a story of the system that keeps Earth stable and what happens when it breaks. Before we continue, take 1 second to subscribe. Documentaries like this take time to create. And the next part is where everything starts to connect. Earth feels solid because it moves slowly, so slowly that the human mind mistakes motion for permanent. But in reality, nothing about this planet is fixed. The ground beneath our feet is floating on molten rock. The atmosphere above us is constantly leaking into space. The climate we depend on exists only within a very narrow window of conditions. Stability is not Earth's default state. It is an exception. What we experience as normal is a result of countless forces pushing in opposite directions. Volcanic heat rising from below, solar radiation pouring in from above, tectonic plates colliding, oceans redistributing energy across the globe. These forces do not cancel each other perfectly. They fluctuate. And when they fluctuate too far in one direction, the system snaps into a new state. History shows us this again and again. Long periods of calm, interrupted by abrupt change. Civilizations are born during these stable windows. They expand, build, and assume the world will behave tomorrow exactly as it did yesterday. But Earth does not make promises. Stability is not guaranteed. It is temporary. And when it disappears, it doesn't do so loudly. It fades until suddenly it's gone. Earth survives chaos because it knows how to respond to it. This response comes from something called feedback loops, natural mechanisms that detect change and push back against it. When temperatures rise, oceans absorb excess heat, ice melt, altering circulation patterns, clouds shift, reflecting sunlight differently. When temperatures fall, ice spreads, albedo increases, greenhouse gases decrease. These loops are not intelligent. They are automatic, but they act like a planetary nervous system, constantly correcting imbalance. The problem is that feedback loops can flip. A system designed to stabilize can become a system that accelerates collapse. Melting ice, for example, reflects less sunlight, which causes more warming, which melts more ice. At that point, the loop no longer resists change. It amplifies it. This is how Earth transitions between climate states, not gradually, but rapidly. Feedback loops are the reason Earth has remained habitable for millions of years, and they are also the reason change, once triggered, can become unstoppable. The same systems that protect life are the ones that can erase it. Earth's history is not a story of balance. It is a story of recovery. There have been moments when stabilizing systems failed completely. During Snowball Earth, global temperatures dropped so severely that ice may have covered the planet from pole to equator. Life survived, but barely. During the Permian extinction, volcanic activity released massive amounts of carbon into the atmosphere. Oceans acidified. Oxygen levels collapsed. Nearly all marine life vanished. During the Paleocene-Eocene thermal maximum, temperatures spiked so quickly that ecosystems had no time to adapt. Species migrated, shrank, or disappeared. In every case, the trigger was not destruction itself. It was imbalance. A stabilizing system crossed a threshold. A feedback loop reversed direction. Earth did not explode. It transformed. These events didn't unfold over millions of years. They unfolded over geological instants. And each time, the planet settled into a new normal, one that bore little resemblance to what came before. Stability failed. Life adapted, but not all life. Of all Earth's stabilizing systems, one controls more than any other: the carbon cycle. Carbon moves constantly between the atmosphere, oceans, soil, rocks, and living organisms. In balance, this cycle regulates temperature and ocean chemistry with remarkable precision. Plants absorb carbon. Oceans dissolve it. Rocks lock it away for millions of years. Volcanoes slowly release it back. The problem is speed. Earth's carbon cycle is designed to work over immense timescales, thousands, hundreds of thousands, millions of years. When carbon enters the system faster than it can be absorbed, balance collapses, temperatures rise, oceans acidify, feedback loops flip. This has happened before, and each time it coincided with mass extinction. The carbon cycle is not just a climate system, it is a life support system. And when it falls out of balance, Earth does not negotiate, it responds. Earth does not change smoothly. It changes in jumps. These jumps are called tipping points, thresholds beyond which systems reorganize permanently. Before a tipping point, change appears manageable. After it, reversal becomes impossible. Ice sheets collapse not because temperatures rise slightly, but because structural thresholds are crossed. Ocean currents do not weaken gradually forever. They reach a point where circulation patterns reorganize entirely. Forests don't die tree by tree. They flip into grassland. What makes tipping points dangerous is that they are invisible until crossed. By the time effects are obvious, the process is already locked in. Earth's past extinctions were not caused by steady decline. They were caused by sudden transition. The planet doesn't warn civilizations with countdown. It waits, then it shifts, and once it does, there is no return to the previous world. Life has survived instability before. Civilization has not. Modern society depends on predictability, stable seasons, reliable rainfall, consistent temperatures. Agriculture requires timing. Cities require infrastructure. Global trade requires coordination. None of these function well under rapid change. Past species adapted biologically. We cannot. Our adaptation is technological and social, and those systems are fragile. When stability breaks, failure cascades. Crop loss leads to migration. Migration strains political systems. Instability spreads faster than any natural disaster. Collapse wouldn't arrive as a single event. It would arrive as a series of system failure. Quiet at first, then overwhelming. Modern civilization doesn't need Earth to become hostile. It only needs Earth to become unpredictable. Scientists aren't guessing. They are measuring ice cores, ocean salinity, current velocity, atmospheric composition, and the data points to the same conclusion. Earth stabilizing systems are under stress. Ocean circulation is slowing. Carbon sinks are weakening. Ice feedbacks are becoming nonlinear. These are not future projections. They are present observation. The planet is still stable, but less stable than before. And stability does not erode evenly. It collapses at the margins first. History shows that Earth rarely gives civilizations a second warning. Once systems reorganize, they do not ask for permission. The question is not whether Earth will change. It always does. The question is whether civilization can remain intact when the systems that quietly support it begin to fail. Earth has survived worse than us. That's the uncomfortable truth. The systems that keep this planet stable were never designed for permanent. They were designed for balance. And balance requires respect, timing, and restraint. If those systems fail again, Earth will recover. The question is whether civilization will, because stability isn't guaranteed. It's borrowed.